Hello everyone, welcome to my YouTube channel, TutorAyodele. Today we'll be looking at chain rule. Chain rule. And before we go to that, please, these are the standard derivatives. I want us to take notes. Please bring out your books, put them down. Pause the video, bring out your book and put them down. They are standard. Nothing can change it, they are constant. And this will help you a lot as far as calculus, differentiations, and integration is concerned. If you differentiate this, it will give you this. This one is general method. Please, if you don't know it, watch my video on general method of solving calculus. If you differentiate this, it will give you this. If you differentiate this, it will give you this. This will give you this will give you this, and the rest. Okay, what is chain rule? Chain rule is used when we have composite functions. What did I mean is that when y is not a direct function of x, we make use of what? Chain rule. For example, if I say y equals to sine x, you can easily differentiate this to give you what? Cos x. If you differentiate sine x, it will give you what? Cos x. It's standard. That anytime you differentiate sine x, it will give you cos x. That one is constant. So if I say y equals to e exponential x, if you differentiate this, it is constant that you will still get this, which is here. If you differentiate this, you still get this. But when y is not a direct function of x, let's say we have something like this, another thing a. When y is not a direct function of x, you make use of what? Chain rule. The same thing here, you can differentiate this easily, but when y here is not a direct function of x, let's say we have another thing s, like 5x, you make use of what? Chain rule. Or you may have something like this, it may be 5x plus 1, you may see something like this. At this point, you make use of chain rule. At the same time, if y is given, or let's say there's a group of, let me just say, addition of terms. When everything are in brackets, what did I mean is this? This is what I mean. Let's say you are given something like this, 5x raised to the power of 3 plus 1. At this point, you make use, let's say you are given a power of 5, or let me just say a power of 6 or anything. At this point now, you make use of chain rule to solve this kind of question, because y is not a direct function of x. It's not direct. You still have power and to bracket all those ones. So you make use of what? Chain rule. All right, let's solve some 1 or 2 or 3 examples under this course. Here with me are some questions I want us to look together. Let's say you are given that you are asked to find the derivative of y equals to e exponential root x. You may be given options like, they may say a equals to x plus 1 close bracket e exponential root x. They may give you similar options. B equals to exponential root x. C equals to exponential root x over 2 root x. And D, you may be given x exponential root x. So how are we going to solve it? If you look at it, you see that y is not a direct function of x. There are some other things attached to it. So at that point, you make use of chain rule. So let's say solution y equals to what? Exponential root x. You can rewrite this as, you can also rewrite it as y equals to exponential. You can rewrite this root as x raised to the power of minus 2 here. Yes, it's still the same. So what are you going to do now? You say, let's u equals to, sorry, before we write this, let me write out the formula for chain rule formula. The formula used here is the y over the x equals to what? The y over the u times the u over the x. This is the kind of formula we use as in chain rule here. All right, so let u equals to what? This, everything here. So we say let u equals to x raised to power what? 1 over 2. Then we have y equals to e exponential. When we have represented everything here to be u, you have something like this. So what are we looking for? We are looking for these two to get our dy dx. So what is the y du? You will look for you will look for a place, a function where you have y with respect to the u. Here now we have u with respect to x, but here we have y with respect to what? U. So let's differentiate this. The y du, therefore the y du, if you differentiate the y du, it will still give you the y du. It's similar like to this, because it is a direct function of u here. So it will still give you the y, it will still give you exponential u. If you differentiate the y du, it will still give you this. Now we said let u equals to this. So we are differentiating u with respect to x, u with respect to x. I hope you are getting it. So we have the u dx equals to, and how are you going to get it? Just as I've said in my previous video on general method of solving differentiations, you will use the power to multiply it. You now subtract 1 from the power, which will be 1 over 2 times x raised to the power of 1 over 2. You subtract 1 from it, minus 1. So this will give us 1 over 2 times x. 1 over 2 minus 1, when it will give you, let's say you find the LCM here, you have 2, 1, 2 here, 1, 1 times 1, we have 1. Here is same thing as over 1. So 1 here, 2, 2 times this will give you minus 2. All right, this will give us 1 over 2x. If you subtract 2 from this, it will give us minus 1 over 2. So that is our du dx. Therefore, the y dx equals to du, the y du. What is the y du? This is the y du. Exponential u times the u dx. What is the u dx? This is the u dx. Sorry, exponent times the u dx. 1 over 2 exponential 1 over 2. Sorry, 1 over 2 x raised to the power of 1 over 2. So if you should multiply this, it will give us u 1 over 2 u, exponential u x raised to the power of 1 over 2. So here we can also solve this one as it's the same. If you use this u to multiply this one, it will still give exponential u to multiply this, it will still give you exponential u over 2 times x raised to the power minus 1 over 2. Exponential u over 2 times, this one can also be resolved. We can also rewrite this one as as 1 over x raised to the power of 1 over 2. Yes, in law, according to law of indices, we can write this one as this. So here we have exponential u over 2, because if you use this one to multiply this, it will give you this. This times this, it will give you x raised to the power of 1 over 2. And you can resolve this one to be exponential u over 2. You can write this one to be root x. So our final answer will be the y dx equals to exponential u. Recall, you represented u with what? X raised to the power of 1 over 2. And this is also the same thing as this. Is the same thing as this. Same thing as this. So we therefore say that our final answer is u raised to the power of exponential root x over 2 root x. So that is our final answer. And the correct answer is option number C. All right.